And it's my pleasure to introduce our speaker for today, the CEO of LAM Research Corporation. Martin Anstis has been with LAM for 16 years. The last 6 is CEO. I learned, he asked me not to read his full bio. He figured it would put you to sleep. But the one snippet that's not in there that I learned in talking to him is that he is a motorcycle riding Brit. So we'll leave that as the intro. And with that, Martin, the floor is yours. Thank you so much for being here today.
Thank you. So I guess that's a lesson in be careful what you say, because we were just comparing notes on where we lived and what our commutes was like, and I happened to make a statement that I rode my motorcycle to work a couple of weeks ago, and I walked in through the lobby in my leathers, carrying my helmet, and one of my customers was like in the lobby, and I was trying to hide so they wouldn't see me, but they did, and they were like completely shocked to see the CEO of the company wearing leathers. But all that said, it is my pleasure to be with you today. This interface is about the most important interface for a CEO of any company, and it's the interface with, I hope, the next generation of talent for our industry and the next generation of talent for our company. And I come here because I have an objective, which is the reality of being a CEO. You have to kind of have an objective for every hour of every day. Number one, because you get paid a lot of money, and number two, because you have a really important responsibility to a lot of people. And my objective is to at least give you a perspective on what I think is an incredibly cool industry with tremendous opportunity to innovate, to create, to be entrepreneurial, and to contribute to the world and make the world a better place for the folks that live on this planet. Or maybe sometime in your life, folks that live on another planet. But at least for now, I think we have tremendous opportunity to make this world a better place, and the world of technology and semiconductors specifically is sitting right at the center of that transition. So we have about an hour, I think. Is that right? An hour? Okay. So I do have some slides prepared. I'm happy to take questions at any point in time. So if you want to interrupt me, please go ahead. I'd much prefer that we engage, as opposed to I just stand and talk to you. And for the folks at the front of the room here that work for LAM Research, they will tell you it is very possible for me to talk for an hour. So interrupt me, and we'll try and get some healthy Q&A. So just a quick introduction on the company. Back in the day, if you asked anybody at LAM Research to talk about LAM Research, they might say, we're an equipment company. So I don't know how many people think that being in an equipment company or being an equipment company or working in an equipment company sounds very sexy. I don't think it sounds very sexy. And I think it really understates what we do. And what we really do is we deliver a result on a silicon wafer like no one else in the world. And what our customers do today is they actually make the world a better place. So what's changed in the semiconductor industry in the last 5 years, there are many changes. But one of the changes is the definition of success for our customers is entirely different. Our customers include the Intels of this world, the Samsungs of this world, the Toshibas of this world, TSMC. That community of customers no longer defines their success in the traditional terms of having devices that are faster processors that are costing less, the traditional Moore's Law definition of success for semiconductor industry. They talk about actually contributing something valuable to the world. They talk about predictive medicine. They talk about autonomous vehicles. They talk about smart agriculture. They talk about a contribution that makes the planet a better place. And that's how I like to think about us today, because that is our space, because we make that possible. Without the ecosystem that surrounds the semiconductor industry, the silicon roadmap doesn't happen. And increasingly, if you ever hear anybody talk about LAM Research, they might use 2 words. They might use the words strategic relevance. And a big part of today's story is about the strategic relevance of LAM Research to the roadmap, the technology roadmap of the world. And we've worked really hard to position ourselves to be much more enabling, much more influential, much more relevant to the success of our customers in their vision. So we are today an integrator, an innovator of complex engineering systems. We're a hardware company, a software company, a process company, a materials company, and a process controls company. We're an integrator of all of that. And that's extremely difficult on nanoscale geometries. It's extremely difficult given the economic challenges of the global economy, but it's a really cool place to be. So we were established in 1980, so we're 30 to 40 years old, depending on whether you want to count public life or private company life. But the company has some great history, and it has evolved quite significantly in the last 5 or 10 years. We currently employ 10,000 people. Actually, one of the things that I like about some of the slides that I'm presenting with you today is they're out of date. And you might say, well, why are you showing up with out-of-date slides? And I'm going to ask that question when I get back to my office. But it actually serves a purpose because it helps me communicate growth. Because it is true to say that at some point in this year, we employed 9,100 people. Today, we employ close to 10,000 people. We have hired 2,000 people in the last 18 months. It is true to say halfway through this year, the last 12 months of our revenues were $8 billion. By the end of this year, our most recent 12-month revenues will be close to $10 billion. We have grown our company by 25% per year for the last 4 to 5 years. So if you're sitting here thinking this semiconductor industry and the supply chain to the semiconductor industry is kind of a humdrum space, it doesn't grow, it's not exciting, you are flat out wrong. And the evidence might be LAM Research because there's a 25% growth curve, and this year, 50. So we're in the process of taking a company that revenued $6 billion last year and revenuing $10 billion this year. We're a company that, not so many years ago, 6 years ago, I think was worth about $6 billion. $6 or $7 billion, I think, was the value of the company. Today, it's worth $32 billion. So a lot of excitement, a lot of opportunity. And what's also out of date on this slide is how much money we spend in engineering and technology, our investment in R&D. So it is true to say that in the last 3 years, we spent $2.5 billion, but it's also true to say that this year, we will spend $1.1 billion. And the fundamental strength of our company and the fundamental asset of our company and the fundamental opportunity for our company is defined by attracting and retaining the most competent and qualified engineering and technology talents to our company as a foundation, and then building a team, a multifunctional team around that group, and together creating something pretty extraordinary. One of the big transitions for our company in the last 5 to 10 years has been expanding a product portfolio. And expanding a product portfolio has a number of objectives. Not least, it gives you kind of options, it gives you choices, it gives you flexibility from a business point of view, and it gives you scale, and scale is helpful. But what was much more important to us as we scaled from being a plasma etch company to a deposition company, plasma and wet, and also clean company, and ultimately a services company as well, that portfolio of products and services is most interdependent, I would say, with the technology roadmap of the semiconductor industry than any equipment company in the world. And so we don't have the biggest portfolio in the industry, but we might have the most relevant portfolio in the industry relative to the technology and engineering challenges of our customers. In general, the academic engagement is incredibly important to us. It's incredibly important to us in terms of partnerships for applied research. It's important to us in terms of scholarship programs. It's important to us in terms of attracting talent to our company. And it's actually helpful to me because one of my most basic challenges is to create a company that people want to join, a company where people achieve their full potential. And so I got a chance to sit in your lobby here and watch you scurrying around from one class to another. And one of the things I realized is I have to allow skateboards on our campus if I'm going to attract you. I'm talking to this guy in the front who actually has the biggest skateboard I've seen ever. That must be super special. But we have a fellowship program, big data focused. We have an advisory member on your College of Engineering board, and we've recruited a bunch of your prior students and perhaps some friends. So there are 240 grads from this school in our company today, and hopefully they're a great reference for you. They're a great reference about what's special about our company and what's great about the opportunity to innovate, to create, and to be entrepreneurial. So we have a little video prepared, and although I am CEO of a technology company, I don't know how to use this computer. So my assistant is going to set this video off. But this will give you a little bit of color on our company and what it is to be an engineer in our company.
As a design mechanical engineer, I develop all of the hardware that you see on our platforms except for the process module sides.
As a process engineering, we design and develop the process that can provide solution to customers' current and future technology.
I work in a team that develops software infrastructure and technology for our equipment.
We do firmware development for wafer handling robot and mechanism.
I develop chemistry concepts for the spin cleaning tools.
I manage the factory automation and the UI development teams here.
I joined LAM because it gave me the opportunity to learn robotics. I took robotic courses in my graduate school and was looking for a position that gave me the opportunity for robotic development, and LAM was one of them. And it's a decision that I never regretted.
I started at LAM right after I graduated from Cal, and I think it was the idea of controlling machines and making them do things that brought me here.
Actually, this was my first job. After I graduated from school, I found that what I have learned from school can apply to semiconductor industry, and LAM is one of the big companies.
Our industry moves so fast that if you don't remain at the forefront, you can completely miss the boat.
We need to develop new products very fast, but also with high quality.
For a semiconductor technology company, the technology is almost everything. So I think engineering's work is very critical for a company.
We are a very fast-growing industry, so you need to be very flexible and find also quick and also best-in-class solutions.
No product at LAM is built by an individual, so you could say that teamwork's sort of fundamental to what we do at LAM.
It's that sense of people looking out for each other. There's no one engineer that knows it all. You definitely need the broad spectrum of knowledge from each individual to contribute to the design.
It starts with everybody being on the same page in terms of what the requirements are, what is the schedule, and how do we work with each other to make sure that we can achieve that.
An engineer's role in the future here is turning the theoretical into the practical. I think there is a scary amount of uncertainty in what we do. We don't always know exactly how what we build is going to behave in all situations. So I think with experience in engineering, you just have to learn to deal with that uncertainty.
The engineers, I would say, are the key persons who have everything in their hands to develop or design our future.
As long as the world is moving towards a different innovative direction, meaning the technology is developing, engineers will always be needed around the world.
So, if I asked you, what did you just see, what would you tell me? If you had to pick a word or two words, what would you say? Innovation. Excitement. Technology. Diversity. Okay. Teamwork. No skateboards. Actually, I was thinking about passion and enthusiasm and teamwork. Those were the things that I was immediately struck by when I watched that video, and I haven't seen it for a little while. But if you asked me as the CEO of the company what I'm most pleased about, actually the answer I will tell you is I'm most pleased about the pride that our employees have, including the engineers and technologists of our company, the pride that they have in their achievements. And everybody defines their achievements objective differently, but collectively, if you show up on a LAM Research campus today, you're going to see a lot of really proud and excited and passionate people who are invested together to achieve something quite extraordinary. So with the end of a video, I'll transition back to this PowerPoint, because this maybe sets some context for what I'm describing in terms of this world of opportunity. So this also is a slide that's out of date, because while it's true to say that for many, many years, the industry of our customers, the semiconductor customers in the world, was a world of $340 billion. In fact, it was $340 billion actually for the last 3 years. This year, it will be a $400 billion revenue. And a big part of that is actually nothing to do with, in its origin, the semiconductor industry. It's all to do with big data and AI and the role that data plays increasingly in the global economy. And from my perspective, that's an entirely new era of innovation. And without the semiconductor industry, without the role of silicon, none of that's possible. It certainly is not sustainable. So I see tremendous opportunity for the semiconductor industry to grow and to define value propositions to the world that are significantly different and better and more comprehensive than was true only 5 to 10 years ago. Our piece of this ecosystem is the bottom one here, the wafer fabrication equipment space. And it's true to say that $34 billion was a number that was not so unfamiliar to us a couple of years ago. Today, our customers will spend between $40 and $45 billion buying equipment. And that's one of the reasons why we've grown from a $6 billion company to a $10 billion company. So that's some context for you. We're part of the electronics industry, big data, AI, trends like autonomous vehicles, augmented reality. That entire world is captured in that reference to electronics. And the semiconductor industry makes it possible, and the equipment industry and the materials industry make the semiconductor roadmap possible. I touched on this a little bit earlier, but this is a commentary on diversity. So one of the interesting things about the semiconductor industry in the last year is there has been a competing tension between consolidation and diversification. And the consolidation has occurred in terms of the number of industry participants. So I get to be the CEO of a company that's a little unusual, and it's unusual in lots of ways. But one of them is we actually only have about 10 customers. Now, that's not entirely true, because there are probably up to 100 customers around the world. But 80% of our business is defined by the spending patterns of 10 companies. So we have an intimacy and a focus on the success of our customers and a focus on building trust with our customers like you would never believe unless you have an opportunity to be part of that experience. And what they're focused on is this enablement of the world. And so as the industry is consolidated, as the number of participants in the industry is consolidated, and that's more about economics and risk than anything else, because today, if you want to build a semiconductor fab, a fabrication facility of any scale, you will minimally have to spend $10 billion. You might have to spend $15 billion. So these are enormous structures. They're enormous sums of money. And that's caused consolidation. But at the same time, what's happened is the device demand has dramatically diversified. So only 5 years ago, if you talk to anybody in my job, they would be talking about integrated circuit units, they would be talking about PC units, they would be talking about cell phone units. I almost never have that conversation today, because the opportunity for our company and the growth of our company is defined by something else. It's defined by this. And this is applications innovation and software innovation. And this was made possible literally only in the last 3 years, because one thing that the semiconductor industry did for the world in the last 3 years is it gave the world connectivity. So how many people don't have a cell phone? Okay, super pleased. No one put their hand up. So we gave the world connectivity. I think there are close to 6 billion cell phones in the world today, and about 4 of them are what we call smartphones, with a lot of content and a lot of applications capability. They're mini computers to the definition of 5 years ago. So we gave the world connectivity. What we also gave the world is something called the cloud, and the cloud is about memory and storage and computation. And the combination of connectivity, a cloud, and distributed sensors, the IoT environments that shows up in many of these applications, has created a triangulation that is driving innovation in the world, in this valley, like never before. And so I'll give you a nice simple headline. From my perspective, I think the excitement and the innovation and the opportunity in and around the semiconductor industry in the next 5 years will be at least as great as any 5-year period, perhaps except for the first 5. So this landscape of opportunity is a statement of diverse demand drivers. It's a statement of opportunity for our company, for our customers, for our currents, and I hope some of you as future employees. So there is an engineering context, and the engineering context is this. So you might have heard about Moore's Law, and Moore's Law was all about transistor density and cost and processing speed. The definition of success for devices today and the challenges for devices are dramatically broader. So today you might hear about density scaling challenges, which forced 2-dimensional to 3-dimensional device architecture transitions. You might hear about dark silicon, power scaling challenges, Dennard's law. You might hear about the thermal challenges. You might hear about RC management challenges, bandwidth. The diversity of challenges for the industry is also exciting and expanding. And again, that is at some level a little intimidating, because you ask yourself, can we actually overcome that scale of challenge? And there's plenty of evidence in our industry over 50 to 60 years that the answer to that question is almost always yes. Someone somewhere in the world will find a set of solutions to overcome every one of those challenges. And I think that's a really exciting part of our industry, because the innovation that's available around the world is quite extraordinary. There are many things I would say about my job from the perspective that I consider myself to be extremely lucky to be the CEO of LAM Research. One of the things I would say about my job is I literally get to work with, not just in our company, but around our company at the customer interface, literally the smartest people in the world. Because the folks that end up stepping into the space of taking on these challenges and this innovation are extremely smart people. And that's one of the joys and one of the challenges and one of the opportunities of being part of this industry. So despite all of those challenges, the good news is there's actually a great roadmap. So one of the legacies of our industry is everybody thinks we're always about to fall off a cliff. Everybody thinks that actually the future of our industry is about to stall or die. And it could not be further from the truth. The most challenging part of this roadmap actually is probably the bottom one, the DRAM roadmap. Because the capacitance challenges in that device architecture are reaching a level of challenge where in today's roadmap of customers, there are only 3 more generations of DRAM. Now, that sounds like imminent stalling of a technology, but what you can see from this slide is that's a transition that extends all the way through to the mid-2025 timeline. So it's a long way off, and that's the most constrained one. This is probably the most exciting part of the semiconductor roadmap, and it's exciting for 2 reasons. One of them is just volume and demand and the insatiable appetite of the world to collect data, store data, and process data. And the technology transition has a huge amount of longevity to it. So we're probably in generation 3 of a 10-generation roadmap by current definition. And every year that passes, there will be another variation on the theme of 3-dimensional scaling for non-volatile memory. And there's something right at the bottom here that is talked about a lot more in the industry today, and it's the world of new memory, cross-point memory, ReRAM memory, MRAM memory. And that shows up in the roadmap because the user community, the servers, the consumers of the world are constantly competing between storage density and read-write speeds. And the last part of this slide is really all about the evolution of specific memory targeted at specific attributes, performance attributes. Again, that's another variation on the theme of diversified demand. The top is all about the Intels of this world, the TSMCs of this world, the Samsungs of this world that drive the processing roadmap of the world, the microprocessor roadmap, the GPU roadmap of the world. The NVIDIAs show up in that space, not directly as a fab, but they're a fabless company and they buy from companies like TSMC. And we support and sell to companies like TSMC. That roadmap, similarly, despite significant challenges in lithography, that industry has a roadmap all the way through 3 nanometer, which again is 2025. So there's tons of certainty. There's a lot of uncertainty as well. But I'd hate for you to leave this room not understanding what a great known future there is for the technology roadmap for our customers, and that's really the purpose of this slide. This is a variation on that same theme. So this tells a number of stories. It tells a story of how the roadmap of the semiconductor industry has evolved because we transitioned from a world of simply shrinking things. 10 years ago, this industry was defined almost exclusively by making things smaller. And the lithography roadmap began to make shrinking things smaller difficult. And then we showed up. And we showed up with a few other people in the ecosystem, but we showed up and started to deliver the industry something called multi-patterning solutions. And that was an alternative to printing features that were small. So it allows our customers to print features that are bigger, and then through the process of etching and deposition, we actually make smaller feature, and that's what that progression is intending to suggest. What we also did is showed up here in the transition between planar structures and three-dimensional structures. And today, the leading non-volatile memory devices in the world have literally 96 layers of alternating oxide nitride film, oxide poly film. That's extremely hard to do because you have lots of stress challenges, lots of pattern collapse challenges, lots of profile challenges. And LAM Research has created a situation where we have 90 to 100% market share of the critical applications in the world that make this device possible. So back in the day, I spent a lot of time on airplanes, by the way. I've spent enough time on airplanes that at one point my kids thought I was a pilot. They're now in their 20s, so they know I have another job and I'm not a pilot. But I spent a lot of time on airplanes, and when you sit on an airplane, usually there's someone sitting next to you. And they might say to you, what do you do? Who do you work for? Where do you live? And when they ask me what I did or who I worked for, we never really had an exciting story, and you'd say LAM Research, and you'd have to go into a lot of detail. And now we can say, literally, every single device in the world of any significance has a chip in it. And that chip, almost by definition, will have been manufactured using LAM Research equipment. So we're the systems guy that makes the production of chips, that makes the production of electronic products possible in the world. And 3D NAND, DRAM and logic scaling, the transition from, again, a planar transistor structure to a FinFET structure to next generation gate-all-around architectures, new materials, new packaging, fan-out integration schemes, and so on and so forth. There's an explosion of diversity in problems and also resolutions to the semiconductor roadmap. So what does that represent? That represents opportunity for all of you. Because if you like to be challenged, if you like to solve complex problems, if you like to be part of a team doing something kind of extraordinary, there's a place for you in this industry, and there's a place for you in LAM. So this is a nice, simple question, and the slide that follows is not really a comprehensive answer, because there's lots of things that have to show up in a company for it to be successful in our industry. I've worked for essentially 2 companies, 2.5, 3, depending on how you count it. And I've worked for both of them for 15 years or so. And I will tell you that from my experience, and I've done a lot of merger and acquisition work in my life, so I've seen a lot of companies and been part of a lot of companies and industries, I will tell you that if you can be successful in the semiconductor capital equipment industry, you can be successful almost anywhere, because the technology challenge is extraordinary and the business and economic challenge is extraordinary as well. But what this slide reminds me to say to you is, without the discipline of engineering and applied research and collaboration, and truly understanding the mechanisms of physics and chemistry and biology that are relevant to the products and services of our customers, we actually are not going to be sustainable or successful. So there's a perpetual appetite to attract and retain the smartest people in the world to the business of semiconductors and the business of Lam Research specifically. Someone, when I asked the question earlier, said, I see diversity, and that's a truly critical part of the success for our industry today, and that's one of the other joys of my job. I get to have a global life. I spend almost as much time out of the US as I do in the US, and I get to work with people all over the world. We employ 10,000 people. 5,000 of the 10,000 are in the US, 5,000 are somewhere else in the world. 80% of the rest of the world is in Asia. 70% of our revenues come today from semiconductor device manufacturing in Asia. Other dominant countries are Korea, Taiwan, Japan, Singapore, and increasingly China. So you might hear a lot about China today. China has committed at the federal level, at the Politburo level, has committed to position itself as a semiconductor manufacturer. And the reason they chose to do that is because they actually import more semiconductor devices than they do oil. And that's really expensive. And so they have defined two objectives, and they are now building semiconductor competency and capability in China. And their objective is national security, and their objective is balance of payments. And those are two enormous agendas that legitimize, I think, the agenda for semiconductor in China. And last but not least, and this is really important, and if I gave you any advice relative to seeking employment, this probably would be the most important advice I could give you. Find a company that has a great culture. Find a company that has values that align with yours, because there's nothing more soul-destroying than spending lots of time and efforts in an environment that you don't enjoy, that you don't respect. There's nothing worse than spending time in an environment where your full potential is not realized. So if you asked me to define very simply what my job is as CEO, I would say maybe 3 or 4 things. Number one, do my best to get the vision and the direction and the strategy of the company correct. Number 2, create more opportunity than any other CEO in our industry to go execute it. Number 3, to create the culture and values in our company that create a situation where our employees achieve their full potential. And number 4, get out of the way and let everybody else do their job. And so this commentary on culture and values is critically important for us. It is what enables, in many respects, teamwork. When you don't have a culture and a set of values that are biased to trust and respect, when you don't have culture and values which are biased to open communication, when you don't have culture and values that are biased to accountability and ownership and continuous improvement, for example, you're not going to be very strong in teamwork and partnership and in collaboration. And there are many things that I would say are special about LAM. This is one of them. And because of this special, we have an opportunity to be the most collaborative, the least threatening, the most engaging equipment company with the ecosystem than anybody else. And that's a big part of what we define as a competitive ambition. And it's a big part of what we hopefully present to our current and future employees. So I'm going to personalize this a little bit, and this is my last slide, and then you can tear me to pieces with your questions. So I've learned a lot of things. I continue to learn things. I learn things every single day. I learned this morning that I don't like wearing makeup. So now you're wondering, why did he just say that, right? So it turns out that I've been actually speaking with a microphone twice today. So my first appointment of the day was at the CNBC studio in San Francisco. And of course, when you're on TV, you have to wear makeup. And so I don't like wearing makeup, and I spent all my time in my limo going back to my house today, like trying to get all this makeup off my face. So I'm super pleased that I wasn't asked to wear makeup here for you today, because I don't like it. That's one of the things I learned. But joking aside, I learned some really important things as well. One of them is that when you have an opportunity to work with people, for people, pick smart people. Right? Pick people that will challenge you to be better. Pick people that you can learn from and learn with. Pick people that will embrace your contribution. So really think about working for smart people. If you just keep picking jobs that have you work for smart people, trust me, you're going to do rather well. Number one. Number two, get as many experiences as you can. So one of the things I notice occasionally when I talk to people about career planning, or their aspirations for promotions, or they're coming into the workplace and they want some guidance on how to think about life in a workplace, I notice that people try to kind of plan it too much. I never did. Maybe my experience is a little bit different. All I ever tried to do was make a difference. I tried to contribute. I tried to be complimentary. I tried to enjoy what I did. I worked really hard, and I ended up being the CEO of the company. I never actually said I want to be the CEO of the company, and I need to do this and this and this. I just enjoyed the opportunity that was presented to me, and I never said no. I always said yes to opportunities. And particularly if you have an opportunity to work overseas, whether it's in an internship program, whether it's a study overseas, or whether it's a work experience rotation outside of the US, go for it, because at your stage in life, it's a tremendous growth opportunity to get an international experience that's different. But functionally, if you are an engineer, if you're a technologist, get as much diversity of experience as you can, because that will help you over time contribute and be a more effective member of a team. Be curious. Never lose that. So if you came to LAM Research and said, hey, tell me about Martin. What reputation does Martin have? They'll say a bunch of things. Some of the things I don't know about. But one of the things I do know about is most people will say he asks a lot of questions. I ask a lot of questions. I ask more questions than I make statements. And I do that because I'm trying to learn to accomplish the objectives I described a few moments ago. It's also a necessary part of a continuous improvement process. If you are never curious, if you don't ask questions, then you're never going to be part of an ongoing kind of trajectory of success. So seek context, ask questions, never stop doing that. Appreciate the importance of emotional quotient as well as intellectual quotient. So what I mean by that is, sadly, I get to see some really smart people that don't quite ever achieve their full potential. And they don't quite achieve their full potential, not because they're not smart enough and not intellectual enough, because they are by a high standard. They never find out how to work in the system of the company. They never find out how to work with other people. And one of the points that was made for me on the video was the importance of teamwork, the importance of working together. The reality of the complexity of our business. Success is not defined by any one person. Success is defined by the efforts of everybody in the company. And that is only made possible when you have the emotional maturity to engage with people and work with people. And I think for your generation, that may be a more difficult challenge than it was for my generation. And a big part of that is the advent of social media. Because a lot of times you communicate with your head down and your thumbs and fingers going crazy on a keyboard. And just occasionally you got to step up and engage and talk and listen and interact as a human being. And I hope that's not lost in the transition of social media. I hope that's not lost in the education curriculum, because the human interface is the only interface that builds trust and sustains trust, and that's only made possible when you learn the importance of trust and respect, and you learn to read signals, and you learn to engage with versatility around emotions. harness the value of diversity. One of the most important parts of anyone's job at my level or at an entry level, harnessing diversity and benefiting from the perspectives and experiences of other people is critically important. So when you think you know everything, remember you probably don't, and you still have something to learn, and always keep yourself open to the input from others around you. Be open to the opportunity that there are many paths to success. One of my actual learnings in the last kind of 5 years actually is how differently people in our company define success. And I started with statements of financial success. That's important because we're a public company, but it's not what most of us are inspired by. Most of us in LAM Research are inspired by delivering enabling solutions to the success of our customers' ambition. And that's all about engineering and technology and operational execution. And it is truly one of the most rewarding experiences possible when you can make some of the roadmaps of the scale of our customers more manageable, more achievable, and more impactful in the world. So recognize there are many ways you can be successful. Recognize that the person sitting next to you is going to define success differently from how you do, and that's just fine. That's all about diversity. And the last thing I would share is never stop learning. So I don't know how many of you are close to wrapping up your education here, but never stop. Never stop learning. However successful you become in your professional life, never, ever stop asking questions, building context, exercising curiosity, and investing in your own education and development. And with that said, we'll open the floor for some Q&A. I guess my closing statement is, there is a world of opportunity, and it's yours. Take advantage of it. If you have questions, I'm happy to take them.
I have two questions, if that's okay. The first one is, how far off do you think we are from completely, like for solid state storage to completely replace like optical storage? And what do you think that will do when we can measure all like data transfer in terms of like gigabytes as opposed to megabytes?
Dave, feel free to join me here, but I think we're a long way off.
A long way off?
A long way off. And actually, you know, one important thing to remember is we're part of actually answering that question, right? And this is the irony and the trade-off when you look at all of the slides I've presented. There are some big challenges, but actually some of the challenges get solved by the equipment industry, by the materials industries, by companies like LAM Research. Do you have any specifics, Dave?
Well, the only thing I would add is that there's going to be a long tail. But the difference is that if you look at the amount of storage today, and you say optical or magnetic spinning media, and you added that up, and then you compare to, we'll go forward 5 years, the amount that's solid state will start to just dwarf it. It's not that it will go away, but the primary thing, you look at every server farm that's coming up and everything, they have to go solid state just because of the energy cost for the non-volatility. And so it'll never go away on the legacy stuff, but it will just become dwarfed. It already is. It's starting to become dwarfed. If you look at sales of bits per, whether it's in solid state versus spinning, it's still, we're still not there yet, but it'll go all solid state.
So for all of you, I should introduce Dave as Dr. Dave Hemker. I'll let you know that Dave is a long-term industry guy. He's a 30-year guy. He's got a tremendous amount of experience. In our company, he has been responsible for some of the most fundamental hardware and process innovation in our company. He was most recently a CTO, is currently technical fellow for our company. So if you want to ask really complex technical questions, he's your guy.
And one other question is, how prevalent are chemical engineers in your company, and whereabout in the world are they most prevalent?
That's a very interesting question. And I think the answer is it's changing really fast. So if you look at the kind of dominance differentiation opportunities for the company, back in the day it was hardware and process development, and back in the day we were a plasma physics company. Today the portfolio of the company tells you something very different, and chemistry and fluid dynamics and so on and so forth is a much more central part to the technology roadmap of the company, and it's much more relevant to the integration challenges that are relevant to our part in the device manufacturing flow. So we spend a lot more time thinking about process interdependency and co-optimization and integration today than ever before. And we go where the talent is available, and we put it where it's needed. So when we attract talent, it ends up being placed where we need it, which in general is next to a customer. Dave, any other additions?
Question? Do you have a cooperation with the Russian company? I just recently moved to the USA from Russia.
Yeah.
So enjoyed the here in Silicon Valley semiconductor guys. So I'm interested in collaboration maybe.
Yeah, so that's a really interesting question, and the answer is yes, we do. But there have been points in history where it's been a lot more. There are a lot of people that are similar to you that have kind of come out of that education system, come out of that environment, and are now here. For one reason or another, the U.S. government puts a bunch of restrictions on industries, and at certain points in time, they've put restrictions on our industry in terms of where we can access technology and where we can share technology. But clearly, back to my earlier answer, we generally seek the talents, the partnership, and the collaboration where it is the best in the world. So if there are attributes of our technology roadmap that naturally cause us to interact in place A versus place B, it happens as a natural course unless there's a restriction on us that doesn't allow us to do that. I think we have one customer in Russia, one fab.
Many of our bachelor's candidates don't know if they should pursue master's degree studies, and likewise, many of our master's students don't know if they should pursue PhD studies. In the semiconductor and related industries, do you have advice for the thought process of what they should consider for advanced degrees beyond the bachelor's?
Yeah, I'd actually like Dave to answer this with me, so I'll give you my version, then he can give you his. I don't think there's such a thing as a general piece of advice. I think there's a little bit of a fallacy that there's a single answer. I think it's really a byproduct of how you best learn and grow. I don't have a master's and PhD. And I learn and grow in the environments of a workplace better than I ever did in the academic space. Now, you might be entirely different. So what I would encourage you to think about is what environment suits you best for the acquisition of knowledge and learning. And I would also encourage you to think that actually it's not a kind of digital event, right? So if you make a choice now, it doesn't mean you can't change the choice later. It might be more difficult sometimes. It might actually end up being a little bit easier. And certainly in some professions, there's an enormous value proposition and often an accelerator when you combine the process of academic-based education with a placement in a company in one form or another. So minimally, get participating in internship programs, get as much exposure to the practical reality of the function and the engineering discipline and the industry that you're interested in, because that will be an accelerator. Dave?
Yeah, I mean, I'll maybe work backwards from it because I agree with Martin. Once you're in, it doesn't matter. I mean, then it's all on your performance. It's, as far as advancement goes. What you can work on will be influenced by your background and your training. So there are certain projects where you really, if you're going to be working on a new source of generating plasmas, that's pretty complicated, and it would be tough to come out of just whatever your undergrad physics is and say, oh yeah, I can make a contribution in kind of coming up with new stuff. So and if you look when we have a job rec for something like that, it'll say preferable PhD. Now it doesn't necessarily, we have exceptions all over the place. So I think one way to do it, if I were in your shoes, is go look at job postings and see when they call out masters, and why, you can pretty much kind of figure out why they're looking for that. And we hire masters, undergrad, PhD, so there's no one right answer.
question? Is your microphone on?
Just yell.
Okay. Like for security, like when you first get into the company, so your company like give you a project to do because you are just first year start on the company, and then they don't want to give you more information, a lot of information about the product. So will you be stuck on like working really limited product, and then you don't have like much practice about to do?
Yeah, I mean, it's a really great question. What we are increasingly trying to do is expose people that come into the company to as much of the discipline of the system that we can. So we have a lot more rotation programs than ever before. I mean, clearly to Dave's point, I mean, what we do is really quite extraordinary, and it is a specialism in almost every attribute. But we do have a big investment in the integration of complex engineering systems. And so the ability to bring leadership and expertise to the integration is as much as important as it is to the subsystem. So the protocol of engaging with people is less to do with restricting people to information and exposure by tenure, and much more to do with the practical realities of protecting confidential information. And we protect confidential information from me in some cases, right? So a nice example of that is when we engage with a customer, we might be working on something that's so critical and so fundamental to the technical differentiation of their roadmap that we have a firewall, we have non-disclosure agreements, and that's information and access is limited to maybe 5 LAM research employees, and that information doesn't get communicated up. So the restrictions, the security, are defined more naturally around the business needs of substance than they are first year, second year, third year entrants. So that's not how we think. We think about getting as much diversity of experience as possible when we're introducing people into the company, building competency and capability, and increasing your value to the company. And frankly speaking, I will tell you that I care about accelerating diversity and breadth early, because if you spend too long in a specialism, it gets really hard for me to take you sideways, right? So if you get to a certain level of seniority, you're now almost indispensable in that function because you have so much empirical learning and expertise and competency that's adding value to the company. I can't afford you to take you out of that function. So we spend an immense amount of time trying to build as much diversity of experience and exposure through rotation programs at the beginning, because it's easier.
Thank you, Mark.
Thank you very much. Appreciate it. Thank you.